Hello and welcome. Today we're going to take a look at the Final Cartridge 3 and, well, you might have guessed it, mine's broken, sadly. Whenever I connected it to the Commodore 64, it's constantly resetting the computer, and I did a few measurements and I found out that one of the logic chips inside is constantly pulling the reset signal low, so yeah, the computer is constantly in a reset states. And I thought about it, oh well, let's repair it, can't be that hard. But then I thought, how about making a new PCB with a bit more modern parts? Because the one I see which broke is a bit hard to find here in Europe, so, well, yeah. I started reverse engineering the cartridge. As you see here, I desoldered already all ICs and reverse engineered the whole circuitry inside. Was a bit complicated, and well, that's the result of it. Looks a bit messy, as with all reverse engineering jobs. Well, let me show you what I made. Zoom in. That over here is the cartridge connector for Commodore 64, nothing special. And this chip over here is a 27C512. This is a UV erasable EEPROM. Yeah, also nothing special. Then over here we've got an SN74LS 163. Can you read it? I hope. Let's zoom in. Too much. Come on. Focus, you bastard. Awesome. 74 LS163, which is just an 4-bit counter, nothing special. That over here is an 74 LS174, which is just a D-type flip-flop, also a standard part. And that thing up here is an 74 LS14, which is an hex Schmidt trigger. Ooh. And that thing over here, that's the bastard. That's an 74 LS133. This is a 13 input NAND gate. I did not know that there were 13 input NAND gates. And they are really hard to find here in Europe. DigiKey and Mouser have some in stock, but I did not want to order some from the US, so meh. And down here we've got an 74 LS09N. All semi-standard part. It's an simply a quad dual AND gate, but this AND gate has an open collector output, so it only can pull the output low, which is a bit special, but still a ready-made standard part. You can still buy it. Yeah. What we've got, two resets, the reset switch and the freeze switch, a few diodes, few resistors, yeah, nothing special, and the LED down there. And that's the replacement. That's the, well, a bit modernized replacement circuit I made. And I took a few liberties with the design. I changed it a little bit. Well, let's start up here. This is the power connector of the cartridge connectors, power pins. First I added a fuse. This is a 200 milliamp PTC self-resettable fuse to prevent exciting fires. Then next I added a 10 microfarad buffer and filtering capacitor at input, well, just to filter it a little bit. And for every IC on the PCB I added a separate decoupling capacitor, just for good measure. And then we came down here. Well, we came to this chip. This is an, oh, can you read it? Come on, focus. You did it before. Come on. Yes. This is an SST39SF0. I used a 10 version. That just determines the size of the chip. This is an flash EEPROM, which means it uses flash technology instead of, well, UV erasable. I ain't gonna put an UV erasable chip in there. Not in the year 2017, no. And yeah, I just hooked it up. There's the address bus. Over there, there's the data bus from the cartridge connectors. Just like the original. I didn't change anything there. As with every flash EEPROM, come on, focus. There is an you can't get that small ones like in the original, so they have multiple address lines, which you can access the higher memory banks. So I just pulled them low, so they are not used. So we're only using the lower memory banks of the flash ROM just to stay compatible with the old memory. Then there is an write enable input, because the flash ROM you can write to it. I simply pulled it high and deactivated it as long as the flash ROM is in the cartridge. I will mount it on a PLCC socket just for that you can replace it very easily and reprogram it if you like. Yeah, that over there I still use a 70LS09 chip, because getting a replacement circuit for this is a bit complicated. You have to put diodes in there because it has an open collector output. Kind of a bit tricky to replace that one, so I just used one of that. It's still a ready available part, so didn't bother. Then down here, this contraption down here replaces the 74LS133, because, well, the part is hard to find, and again, I ain't gonna put a 13 input NAND gate on one of my PCBs. No, I simply refuse. Over there's an 74HC134. That's just a D-type flip-flop, just a HDC version of it. Pretty much wired the same way as the old one. Same thing with the counter up here. I simply replaced it with an HDC version. It's a 74HCC163. Yeah, hooked it up the same way. And down here we've got our freeze and reset switch. I changed it a little bit because I changed it a little bit. I put on the freeze switch, I put a pull-up resistor on there because there wasn't one. They were relying on the leakage current or on the internal circuitry of the chip, which I don't want to. So simply putting in a resistor to pull the line up, just for good measure. Yeah, that was that. That's also the same. Over there I also put in a pull-up resistor. Wasn't quite sure what they are trying to accomplish here, but I think putting there a pull-up resistor is the right thing to do. Well, we'll see. There's our LED. Pretty standard. Yeah. And over there I also put in a pull-up resistor. Did not know. Was there one? I think I added that one also. Shouldn't be that much of a problem. And yeah, I have absolutely no idea what they are trying to accomplish here with this circuit. It's completely strange. Well, the reset circuit down here is pretty straightforward. Yeah, just a capacitor to debounce the switch, and then simply pulling the reset line low, and with another reset signal they are resetting the flip-flop up there. But I have absolutely no idea why they have a D-type latch in there. I have absolutely no idea why they have a counter in there, and what they are trying to do with this, well, contraption down there, or in the old circuit with the LS133. I assume it had something to do with the freeze mechanism of the cartridge. Well, I'm not quite sure. I think if you freeze the cartridge, it will, where is it? It will trigger the non-maskable interrupt of the computer, and then they will, I assume, wait for some state of the until the computer is ready to accept it and then switch to another ROM bank. But I have absolutely no idea how the internals of the Commodore 64 work. I simply copied the original circuit here. And for the PCB layout, well, let's wait to close. That's the PCB layout also. It's just a replication of the schematics just on the PCB. Over there we've got a fuse, filter capacitor. Around the perimeter I added the ground. Well, and I also put in a ground pour over the complete thing, but I just drawn the ground around at the perimeter. That down here is our PLCC socket for the flash ROM. Yeah, that was a bit annoying to route, I have to say, because these lines they were lined nicely, but these and these I had to put in an artistic twist. They were exactly 180 degrees rotated, so I had to put in an artistic rotation in there. I don't know, but turned out nicely, I think. Yeah, there are a few chips. Also nothing special. Up here we got our freeze switch. There's a reset switch. There's a LED, and yeah, nothing special. Of course, I already have my PCB made. Zoom in a little bit. Also Mapleworth electronic, very nice. Looks pretty sexy in this gold, with the gold finish. And yeah, I think I stopped talking. I think I simply start, well, soldering it together and see if it works or if everything in my computer catches fire. Well, we'll see. Okay, let's try to download the firmware of the EEPROM. Well, got my EEPROM here. Let's put it in the right way. Well, let's see if we can read the program. Okay, read. Come on, read. Start. Ah. Yoo! We've got a program. Awesome. Okay, let's save it. Final Cartridge 3. Okay, we saved it. Now we put our PLCC adapter on there. That's pin 1. Didn't use it that often. That way. Okay. Put in our flash. There's one. Okay. Let's select our device. We've got an SST, flash SST 39SF. And PLCC socket. Okay. Now, let's program the device. Okay, it's programming. Awesome. Program okay. Let's verify. Start. Verify. Okay. Okay, it seems you have programmed flash. What I will do now is assemble the Final Cartridge 3, make a few checks with the multimeter to see if I soldered everything correctly, and then we'll see us again and try it out. Let's see if it catches fire. Okay, I've tested everything with the multimeter. Looks good. And I've populated the flash ROM. Well, let's test it. Let's see if it catches fire. Well, it fits in the slot. And fingers crossed. Ha! It works! Yes! Does do anything? Yes! How do I... No, awesome! We go into basic. Yes! Well, can you see anything? I don't know. Should zoom in. Let's zoom in a little bit. Okay. Let's try the reset button. Ooh, reset works. Awesome. Let's restart the machine. Ooh, strange capture. Okay. Seems that it works. Let's power on the floppy and try to... it's ages since I used this in disk. Can you read the directory? Oh my god. Yes! Works! Awesome! Okay. There we go. Okay, basic. Warning! You're leaving the desktop. Oh my god. Okay, does the function button works? Yes, they work. Okay, now the final test, does the freezer work? Ooh. Yes! Yes! Also works. Awesome! Ah, I forgot how to use it. Awesome, it works! Yes! Nice! Finally, I don't have to wait 2 minutes to load the game. Yes! Well... I hope you liked the episode. I'll link the schematics and the BOM down in the description. And, well, I hope you liked the episode and maybe we see us in the future. See ya!